Kommen wir zum nächsten Vortrag. Alain und Jakobu, bitte nach vorne. Und der Vortrag lautet SatDump for Weather Satellites, CubeSats and Deep Space. And the microphone to you.
Thanks. Yeah, well, that will be useful.
Thank you.
Take on, guys.
And I guess I can use that. Nobody saw anything. Okay, so should I start? Okay, so as you might have been told already, and we will be presenting our software. Well, personally, I am the lead developer of SatDump, and he's, well, I mean, one of the other developers, you could say, but it doesn't really work like that in practice, which is, oh, actually, I forgot to ignore the juice decoding, that's for later. But so, we are just going to be presenting the SatDump software, which is basically meant to decode satellites in general and handle pretty much anything required from like actual reception down to actually using, like decoding, then using the data for actual scientific use, if possible, which is another issue. So to begin, the general process you will go through when using the software, or to be fair, when doing satellite reception, would be first to use some sort of antenna. So here is the dish I have in my garden. Nothing really that special, and you don't really need such a dish for what we're going to show anyway. Though for some of it you will need the one we're under, but that's another story. So after just receiving the signal, then you're going to record or process the IQ after receiving it with an SDR of some sort. Then SatDump is going to handle all the demodulation and decoding. So here is just an example. I'm not going to go into the technical details of how that works because it's far too long to hear. And after that step, you get some frames, which are pretty much nearly as close, like it's as close as we can get to what the satellite transmitted as far in bits, if you want. And then SatDump also does all the processing required to extract an image, such as this one. And this one is from a Russian weather satellite that goes over the poles. So then I'm going to let Jacopo explain what we see here, and yeah.
Okay, so Alan talked about his big dish at home, but you really don't need that. And in fact, I'm pretty sure at least one of you in this room already knows what the antenna there is for, because most of you probably have done some sort of APT 137 megahertz band weather satellite reception. And of course, until less than a month ago, we had 3 other satellites in this band that transmitted in an analog format most of you are familiar with, which is APT. Unfortunately, due to politics, this is no longer the case because the satellites were all working fine, but I know. It is what it is. So if you look at the image over there on the FFT, you can actually see all 3 NOAA satellites. That's no longer the case, but fortunately, there are still the Meteor satellites that transmit in the same VHF band with a similar SNR, so you can get much better imagery from them. And the images that are down there are from the Meteor satellites. That's just 2 images stitched together, and SatDump can stitch multiple passes together really simply. And as you can see, here is another example of data usage. This is a comparison of data from NOAA 15 and an actual professional weather service, which is our Italian weather service, Meteoronautica Militare. And as you can see, except the colors, the images are exactly the same, the data is exactly the same, so SatDump can really output quality data ready for scientific usage.
And just one thing to take into account is that since one of them is from a GEO and the other from an LEO, the difference we are seeing is totally expected. And if the same image you see on the right had been produced using a similar LEO satellite, it would have been perfectly identical.
Yeah, and this is where I basically come in, and this is this is what happened when politics gets in the way of science, and the money kind of runs out. And the people that actually are supposed to operate these satellites don't have a clue on how to operate them. And this is actually the death of NOAA 15 when they actually disconnected the batteries, except they did it wrong. And once it was basically disconnected, as you can see in the lower images, it was supposed to be dead, and then on the next orbit, once it reached the terminator again, the eclipse was gone, it started back up. Except that at that time it was completely rotated and in a very unusual situation. And here you see the AVHRR, the sensor, is trying to make sense of the satellite which is tumbling. And the other processing stuff that is producing the APT is completely blank because, it's not supported. Another time, with NOAA 19, they claimed that it had a battery failure, so that was the reason for the decommissioning, except that this reception was done at night, so the batteries obviously were working because it was eclipsed. Unless it had a magic powerful source on board or some dragon, I don't know. And the other thing you see the little burst and the fact that there is only one ball in the PM demodulation. That is because they're running it in a very unsupported and mode, which is not supposed to ever happen on the satellite because it can actually damage the power amplifier, which is they basically have the HRPT signal, which is the high-resolution satellite signal, completely turned off, only the telemetry, and then blank frames, which is something that should never ever happen on a satellite. And this happened supposedly with the battery dead.
And just to add, but we could also decode all the telemetry from that signal, and we could tell that all the instruments were actually running at the same time. So even though the battery was supposed to be dead, everything was still running, and it was even still producing imagery, just not transmitting it. But anyway, that was more of a separate topic we wanted to cover because it's kind of related to what we're presenting. But yeah. And I guess.
Yeah, and this is another typical setup you can use, just a small Wi-Fi grid dish, or the dish you can actually, some of you have seen outside the small helicon I brought today. This can get imagery from the HRPT signal in the L band, so 1700 megahertz. You can see images from METOP and Meteor satellites, and scattorometric radar SCAT from METOP. And if you go outside later, you can see the model of METOP, and it's the three arms below it. It makes images of the, not images, it calculates reflection of the waves on the ocean, so you can infer the winds from that. You want to say? Okay. And these are other examples. Okay.
Yeah. No, no, I'm just saying that because basically this part is about, like, as you might know, over the US, there are the GOES weather satellites that a lot of radiometers capture literally all the time and publish very nice imagery. But in Europe, we don't really have that anymore because EUMETSAT, once again, for more political reasons than anything technical, decided to shut the equivalent downlink down. So it cannot be done in Europe anymore at the moment. And but at the time, since we couldn't receive anything, we were looking into what else we could receive if it wasn't Meteosat. And that was around 2019 with a friend, which is also another developer of SatDump in Poland, who set up this dish to receive a GOES satellite that the US military had moved over Europe to image the Indian Ocean. And we weren't really supposed to receive it, but we managed to anyway, because it cannot be encrypted anyway. And following that reception, they decided to make the data public again, even though initially the DoD was keeping it closed. So yeah. And otherwise, you can see, well, that's an example of the GOES satellite over the US, and that's a Russian satellite at a similar position as the GOES we can receive. It covers Europe a bit worse, but it's a lot easier to receive. So that's just an example. But yeah. And I guess, yeah, I should probably do that part.
Okay.
And yeah, we didn't really, it wasn't initially planned for Jacopo to be here, so we kind of just did it on last minute. So here, if you go up a bit in frequency, up on the S-band, but that's still mostly low Earth orbit stuff, you can receive, for example, the PROPA satellites that you can see here. So they give you some sun imagery in the extreme ultraviolet range that is pretty close to the X-ray range. Not something most astronomers can do on Earth usually due to something called the atmosphere. Then this is from a JAXA satellite that does a similar thing to PROPA 2, but a lot more professionally because it wasn't experimental, and it also, so for example, it does the same kind of imagery you see here, but at a much higher resolution, where you can actually see some details, and in a lot more bands that you can also see here. This one is dead, but it used to be a radar that allowed you to see clouds. This one is from the JSON, it's the JSON radar that allows you to measure sea and wave height. And this part was actually overland, which is why it's so noisy. It really doesn't look at that. And this is from the Proba-1 satellite. It's 5 meters per pixel imagery that you can just receive in the clear whenever they decide to transmit it. That's also from Proba-1, but unfortunately they decommissioned the instrument 2 years ago. And this is from the DMSP military satellites. I know they're military, but they're still weather satellites and unencrypted over some parts of the world, so that's over the US where they are unencrypted and where you are allowed to actually receive the data.
And I just wanted to add something on the DMSP. They planned this year to shut them down and, well, basically not shut down the satellite, but just stop distributing the data. And there was an outcry in the meteorological community because this is very valuable data to analyze hurricanes. And then we stepped in and we kind of decided to have a go at decoding the data. We succeeded, and it got enough traction that it got published in the Register newspaper. And after that, supposedly, the plans magically vanished.
Because we were basically planning, since they were going to cut the data archive, they would stop providing the data on the internet, but we could still receive the data ourselves using, just dishes and providing the data online to then whoever wanted to use them. So we were planning to set up a ground station network to keep providing the data anyway. And following that, let's say that I got some information from somewhere that what we did might have had an impact on them not terminating the data access. And okay, so a few more examples that are starting to be a bit harder to receive. So, what? So here you can see something that was easy to receive but is now encrypted. That was the Falcon 9 video stream. There, that's UVS CubeSat, which is also very easy to receive, and it's a French CubeSat that does high-resolution imageries on some other science. That's from a Blue Walker 3, actually, that was mentioned a bit earlier, and their S-band was just encrypted, and since a few people were monitoring it, and at some point we just saw something that looked like it was a lot of data, and looking at it, I just saw it was imagery and wrote a decoder and published it. And if you use a slightly bigger antenna, that is something like what we're under right now, you can start to decode stuff, let's say weaker stuff like Discover, which unfortunately is dead now, at least for now. But you could get some pretty nice imagery like this one. And actually, we forgot to put the solar eclipse there, but we could, like on this one, you could actually see the moon and similar stuff. And I have some color imagery I made for the eclipse a while back with Peter, but I forgot to put it there.
Just for context, the Discover satellite was at the Lagrange L2 point. Yeah. So you could see the moon and the Earth at the same time. Okay, so here we have X-band. This is the ultimate goal for any amateur that wants to receive high-resolution data, because most of the high-resolution data is there, especially high-resolution weather satellites. For example, we have some Fengyuns over there, some NOAAs, and the Sun is actually from a weather satellite, which is called the Fengyun 3E, which does both Earth imagery as well as solar imagery, so combined. And the city lights are from the NOAA 21 satellite, and that's also another weather satellite that is supposed to replace the older NOAAs, but fails at doing that, but that's another story. And the first image, that's Fengyun 3D, which was one of the easiest, and still is, because it's still active and will be for a long time still. Quite an easy satellite to receive with very nice imagery, very useful also for the scientific data they provide.
And here it's just an example of what you can use as an X-band feed. That's a pretty basic one, but it works. And okay, here it's even, I guess you can do it.
Yeah, so here we have some more exotic X-band stuff. So first of all, you all know probably from Google Earth, the Landsat satellite series. This is a reception from Landsat, because it turns out that Landsat transmits indirect broadcast unencrypted with 245 megahertz of bandwidth. So people were talking about 80 kilobits being, 80 kilohertz being a huge bandwidth. This is 245 megahertz. This is the TIRS instrument. This is an instrument designed to detect fires and to analyze them. Next, we have the Meteor M24, KMSS instrument. It's the same Meteor that does the images on VHF, but it also does on the X-band high-resolution imagery, 60 meters per pixel. And this was the Bay of Naples when there was the fire, and actually had to provide this image to the firefighters to help them tackle the forest fire. And then next we have Electro L2, geostationary weather satellite. And then we have some dumps from Fengyun, 3D, I think. Some 3F, okay. MTVZA dumps from Meteor, so they cover the whole world in the microwave spectrum. And then next, I can't remember that's to.
Wait, which one?
The small one.
This one?
Yeah.
It's just Electro L2 infrared.
Oh, okay. I couldn't see it from this angle. Yeah, it's still L2, but the infrared band.
And so, on the opposite of what I said earlier, there are satellites you can receive easily in Europe, but they're on X-band, which is a lot more expensive. So that's why Electro is separate from what I mentioned earlier. So there, it's a few more examples of a CubeSat you can receive with SatDump right now. That's the Tubin satellite from the University of Berlin, and it just transmitted PNGs on X-band. So we just tracked it and got a signal, and I published a decoder as well. And the video you saw here, we actually made before themselves actually processed the data. So they were kind of making a joke of them not even needing to process the data themselves anymore because we were just doing it anyway.
As you will see, it's going to be a common theme in this presentation of
it
us.
Definitely. Oh, we forgot to put up SG actually.
Yeah.
Okay, so there it's another thing. So if you remember earlier, I said that Meteosat was not transmitting anything easy to receive, but that's only if you don't, because like at some point every satellite needs to transmit their data somehow. So even though there wasn't anything easy to receive, they still transmitted the data somewhere, and it happens that they were just really weak. So with a bit more gain, that is a 4-meter dish, the same friend who did the GOES in Poland built to receive Meteosat specifically, we were able to get enough signal to decode the raw data downlink that, of course, they cannot shut down. And yeah. And now switching on more DSN stuff that I see Peter is already recognizing. Given a bit more gain, you can do a lot more stuff. So for example, when Juice was launched, Bochum started tracking it, of course, and we got some data on everything, but at the time they didn't do any imagery we could receive. But when it came back near Earth for the lunar and the Earth flyby, we could get more than enough signal to get viable data. And right after it basically came, during the lunar flyby, it came near the moon, started doing some imaging, then started transmitting again. And when it started transmitting again, which is what you see here, literally, looking at the data, I just saw that there was imagery and started decoding it. And that's some of the stuff you can see here. So just looking at the raw data, don't look on the right yet, but if you look here, you can see something that looks like stars just in the raw bytes. Here, it's the same thing, but before extracting this part, and that's just the same thing in bytes, because if you can see stars here, you can also see that here you have something that looks like a first image, another one here, and something that changes here, which is just one of the many examples of what I need to figure out to know exactly how to extract data, and basically then get those two images here. So ignore the fact that they are literally shifted left and right. That's because I hadn't figured out the protocol perfectly right yet, and was just so excited to have gotten the first image, and so was Peter, that I published it. And with a bit more work, actually that should be animated, but it isn't. But we got like the entire flyby and made the entire animation before ESA got the data themselves. So the team was quite impressed and wonder where the data was even coming from. And for example, with those images, okay, there. Those two images were actually not even meant to be published at first because they are from the navigation camera. But since we got them and published them anyway, you know. So the funny thing in the end is that for about 24 hours, the first images published from JUICE were from Bochum and decoded by SatDump. And oh, actually no, it is animated here. So, and as you can see, after a bit more work, they were also in color because, of course, it wasn't really standard and it did quite a bit of work. So that was like basically all the stuff you've seen earlier was done at like 1 a.m. or something. I was literally downloading the data from the computer here every few minutes to work on it at the same time. And then I waited overnight for it to dump while we were still emulating here. And in the morning before heading to work, I made those 2 animations and posted them. And that's another thing that Bochum decodes, but usually that's a story that involves both Bochum but also more the general amateur community, because usually like JUICE you need a huge antenna to decode something from most DSN pros, but stereo 2 years ago was coming back after around 17 years, which meant that, let's say that when you have a signal that is meant to be received from the other side of the sun and it's coming back near Earth, it's pretty easy to receive. So instead of needing a dish like this one, you could decode it on this.
60 centimeters.
And it was Scott Tiley in Canada who basically was looking at the signal like that, and since I already had a decoder in SatDump from recordings Bochum and the radio telescope in China had given me, I already had a decoder, and Scott just basically played with it and discovered that it did decode on his dish. And basically from there, the idea was to make it like easy enough to decode, and since it was in SatDump, everyone started doing it. And with a bit of work, and especially a lucky find on a NASA website, I figured out, because like in that downlink, it was supposed to have images, but we couldn't decode them until now, even in Bochum. But with a bit of research on the reverse engineering, I figured out that this executable on a, let's say, relatively hard to find part of a specific website was actually exactly what we needed to extract the data. So with a bit of work and figuring out how to use the executable and so on, we started getting this kind of images. And here that's actually Mercury passing near the sun, but yeah. So a lot of the data that we have here is actually data that NASA doesn't have up to this day, because their own ground station, like for example Bochum, collects part of the real-time data. Some other DSN stations or some other stations do it as well, but over the Pacific Oceans, none of them do. So some of the data received by amateurs, for example, on the east of Australia or on the west coast in the US or Canada, could receive stuff that nobody else could. And that's another amateur who got just a comet on stereo, which meant that it was actually useful for astronomy to receive stereo at the same time, which is kind of funny. And there it's just done, and I guess do you want to say something before?
Yeah, as you can see, SatDump is a very flexible program, so the way you use it depends on the kind of people you are. If you're more interested in the scientific data, like me, you might be interested in the weather satellites and the Earth observation satellites. If you're just a radio amateur that loves to do shortwave, you might be interested in receiving JSON 3, which can detect the radiation of the higher ionosphere and build a map of the radiation on the higher ionosphere, so you can do the QSOs more effectively. And else, if you're just interested in looking around and listening for strange signals and trying to decode them, that's also another thing you can do. So, yeah.
So, of course, everything you saw here was decoded with SatDump and so on, but for anyone who follows the project currently, also I might want to say that everything there in the software is GPL v3 and just on GitHub like that, because
open source, no closed source, yeah.
Just
no payment required, no license.
The only closed source thing is the NASA software for stereo.
Which is actually open source, but I cannot find the source.
No, it's not open source.
Really?
Because it's some algorithm from the Department of Defense.
Oh, okay. Because on their website it says it's open source, but they lie.
It's meant to be, but it's not. So, and the last thing to say is that at the moment it's a bit quiet because we're working on a new version that's So basically, right now we're on 1.2.3, and 2.0 is being worked on. So a lot of the stuff you saw here, I mean, not the imagery or anything, but the GUI and the way things work, like the automatic tracking, the DSP and decoding or whatever, is getting fully redone because SatDump has a lot of legacy code from even before SatDump was even a thing, because like the project started around 2020, to give you an idea. But I didn't even know how to do most of that, so it was just to say that. Yeah. So I guess that's it, and I think someone there is going to ask if you have any questions, so I might as well.
Okay, guys, that's amazing. And Peter.
It's not only amazing, it's absolutely outstanding. I think I have never seen such a software and the capability, and we only saw a little glimpse of it. But I heard that even ESA, and I know a lot of commercial ground stations are using your software now. They probably saw it on the Bochum live stream. Yeah. I'm so grateful for you guys that you are doing this software for free, basically. You're helping us a lot here, and it's the next level. It's really fascinating. Thank you very much.
Please applause for.
Yeah. And look at them. You see they doing that from their heart. They are burning for it.
And yeah, just because I wanted to say that, but since Peter said it, I'm going to add on that real quick. It is used professionally, both in the, like on the more, you could say, meteorologic side of things. Like some people are actually doing actual weather predictions using the data from SatDump and SatDump to produce the images they need to do that. And as Peter said, even ESA nowadays is interested in using the SatDump to some extent on their ground stations, and quite a few satellites, including some of the CubeSats I showed here, are using SatDump on their own stations for like automated tracking, decoding, and everything.
I just wanted to add a funny thing again. One day I was looking at the weather report on some Italian TV channel, and I noticed that the weather map was a bit too familiar for my taste. The colors were a bit too familiar, and it was, kind of suspicious. And then I started asking around, and it turns out that a friend of mine works in this TV station and has started using SatDump to get the data from UMETcast and to project it and then send it to the TV station to actually display it on some Italian TV channel. So yeah, that was a lucky find, but it is what it is. I mean, I won't complain.
Okay. Another one, please. And we have a question. Arno? Please.
Arno Delta Lima 2 Sugar Sugar Bravo. Thank you very much for your talk. I'm really impressed. I have actually compiled SatDump for myself, but never decoded any signal yet. I got a question. You mentioned a signal that was around 250 megahertz in bandwidth. Yes. If I got it correct, yeah. Have you actually decoded this signal with SatDump, and if so, which hardware did you use and which computer?
So actually, I did receive Landsat myself at home on the dish. Not that dish I showed you, but another one that's a bit smaller. And we did it at this place when I was over in Italy on just a 120 centimeter dish.
And the computer is over there if you want to see it.
It's not a big rack. No, it's just a laptop that can do absolutely everything. But so I just record IQ, and then SatDump does all the processing. And the SDR I use as of now is just an Aronia, just a Spectrum that does 245, and that's enough. It's also enough for doing Meteosat 3rd generation, but that's encrypted, so it's a bit useless. And but if you want to buy something to actually do it, I would rather direct you, especially if you can buy it at university prices, towards like an RFSoC or something similar, because that will do like 1.6 gigahertz of bandwidth. So it depends, like the hardware doesn't really matter, it depends on what you are looking at doing. And first of all, you also keep in mind that a single Landsat pass in IQ at 8 bits is already 500 gigabytes. So, and the CADU, that is the actual frames you get out of SatDump, for a single pass are about 25 gigabytes. So keep that in mind before actually looking into doing it.
Okay, Arno? Okay. Another question? Okay. Now other question. I say applause for these two guys. And thank you for all. And that's for you.
Thank you.
Thank you. Bye-bye. Okay.